Hi guys, in this video we'll be solving this problem Xor queries of a subarray. So let's first understand what the problem says. So in this problem we will be given an array of integers, so it will contain some integers. Let's suppose the values are 1 2 0 0 2 0 3 4 5. Any values are given to us. Along with this we are also given an array queries. The queries is a two-dimensional array, so it will be something like this. It will contain k rows and each row contains what? Two indices, that is a starting index and ending index. Okay, so let's suppose there are k rows in this query array, so each row will contain a starting index and a ending index. Let's suppose 2 and 5 is given to us. So what does it mean? That what we have to tell, give me a second. Yeah, so we have to tell the answer of each query. So if 2 and 5 is given to us, so we have to tell the XOR of all the elements from the index 2 to index 5. That is, we have to tell the XOR of these elements: 0 XOR 0, XOR 0 XOR 2. This is what we have to tell. Okay, so similarly k queries will be given to us and we have to tell the answer for each particular query. Let's suppose that first query is 2 to 5, second query is 3 to 4, third query is 4 to 6, and so on. So we have to calculate the value of each query and we have to store it in an array, and finally we have to return this array. Okay, where the ith index of the array contains the answer to ith query. Okay, so this was for the problem part. Now let's see how we can solve this particular problem. Okay, so one way of solving this problem is that one by one we will start with the query array. We'll start one by one with each query. First query, let's suppose it is from si to ei. So what we will do, we will start from si, we will traverse the ei, we will calculate the XOR and we will store it in our array. Then we will move on to the next query. Again, calculate means traverse on this array, calculate the XOR, store the result and move on to the next query. But this way of solving this problem is not very good idea. Like what we are doing in this particular way is that each time we are traversing on this array, right? So traversal will take us what? Order of n time. Like if the array size is n, so we are roughly traveling this array whole. So means we are roughly spending order of n time over here. Okay, along with that the length of query array is, let's suppose, k. So we are taking order of k into n time for solving this particular means problem. But this can be solved in a better way. So let's see how we can solve this problem in a better way, like how we can optimize it. So another way for solving this problem is that we will maintain another array, okay, of the same size as the original array. So let's make another array. Yeah, so if what we will be storing in this array is that at each location in this array, if this is array, this is original array, let's name it as XOR array or something like this. Here at what I will store at each location is that at a particular index, here let's suppose here what I will store XOR of all elements from 0th index to ith index. Okay, so here I will store, if this is 0 1 2 3 4 5 6 7 8, so here I will store XOR of all elements from 0th to 3rd index. I will pre-compute the XOR of all the elements. So here I will store XOR of all elements from 0 to 3. Here I will store XOR of all elements from 0 to 6th index, and so on. So if I pre-compute this array, so this will help us to calculate the queries in order of one time. Earlier I was spending order of n time for calculating the query, means each particular query, but now I can do it in order of one time. Let's see how we can do that. But for that we need to pre-compute the array, means we need to fill it. So here what will be stored at here, 1 will be stored here. At index 2 what will be stored? Index 2 it will be stored. Let's whatever will be the result of 1 XOR 2 will be stored over here. Here what will be stored? 1 XOR 2 XOR 0 will be stored over here. Here what will be stored? 1 XOR 2 XOR 0 XOR 0 will be stored here. 1 XOR 2 XOR 0 XOR 0 will be stored over here, and so on. This particular array will be filled. Okay, now let's see how it will help us to calculate the query in order of one time. So let's suppose now that we will travel on the query array. Okay, if a query comes something like this, that let's suppose the first query is to calculate the XOR of all the elements from 0 to 6 index. Let's suppose the query is of this form. Then we can simply answer it in order of one time, because at 6 index what I have stored? I have stored query of all the elements from 0 to 6. At 7th index what I have stored? Query of all elements from 0 to 7. So if I want from 0 to 6, I will simply return whatever will be stored at XOR of 6th index. I can simply return. So this I did in what order of one time, because I had already calculated the answer. Earlier what I was doing, I was traveling on this array, so I was using order of n time, but now I am able to do it in order of one time. So this was the first type of query. Second type of query could be something like this. Let's suppose a query comes something like this, that calculate the XOR of elements from index 3 to 5. Okay, so index 3 to 5, that is, let's suppose that is these elements 0 to 0. Okay, let's suppose the elements here were originally a1, a2, a3, a4, a5, a6. Okay, so we want XOR from 3 to 5, that is we want a3 XOR a4 XOR a5. We are interested in this. Okay, so what I'm saying, that it is at index 5 what we have stored. At index 5 what we have stored? XOR from 0 to 5, right? And at index 2 what we have stored? XOR from 0 to 2 is stored at index 2. If we XOR these two values 0 to 5 and 0 to 3, it will be equivalent to what? 3 to 5, right? It will be equivalent to 3 to 5. We know that a XOR a is what? A XOR a is 0. So here 0 to 2 part will come 2 times, and they will cancel out each other, like a XOR a will be 0. Let's see how they will cancel out each other. Let's see. Let's suppose what will happen is that 0 to 5 we can write it as what? a1 XOR a2 XOR a3 XOR a4 XOR a5. Now I'm saying that to XOR it with what? 0 to 2. So 0 to 2 will be what? a1 XOR a2 XOR a3. We are looking for what? 3 to 5. 3 to 5 is a4 a5 a6. Here, sorry, here it is mistake. 3 to 5 is a4 a5 a6. Okay, so it is not a3, it is a4 a5 XOR a6. Okay, so and 0 to 5 is what? a1 a2 a3 a4 a5 XOR a6. Okay, so and 0 to 2 is a1 a2 a3. Okay, now if we see clearly, a XOR a is what? 0. So a1 XOR a1 will be what? 0. a2 XOR a2 will be what? 0. a3 XOR a3 will be what? 0. So we are left with what? We are left with eventually a4 a5 XOR a6. Okay, a4 XOR a5 or a6, and this is what we were looking for. So we are able to achieve this type of range, that is range a to b, where a is not 0. We are able to achieve it also in what? Order of one time. And earlier we were scanning this array, means we were wasting, means using order of n time to solve this problem. Now we are achieving it also in order of n time. Okay, so how we will solve these particular queries? If we have something like this a to b, so we can write it what? 0 to 5 or 0 to 2 means 0 to b. 0 to b is stored in what? XOR of b. So XOR of b XOR of a minus 1. Okay, we can write something like this, and we will be able to calculate it in order of one time. XOR of b will be what? Like in this case we want from 3 to 5. So XOR of b is what? XOR of 5 XOR of a minus 1. A is 3, 3 minus 1 is 2. So XOR of 5, that is XOR till this particular location. We have already stored at this particular, means at our pre-computed array. At XOR of 5 we have what? We have stored XOR of all elements from 0 to 5. XOR of 2, what is stored at XOR of 2? XOR of all elements from 0 to 2 we have already stored in this array. So this will cancel out each other, and we will be left with only the answer part. Okay, so this is what we are going to use in our coding part also. So now let's try to code this problem. So for this we will be needing another array. So let's make another array of vector 1 dot size. In this we will be storing 0. So vector 1 of 0 will be same as what? Not vector 1, array of 0 will be same as vector 1 of 0. Now for integer I equals to 1, I is less than vector 1 dot size plus I. What we will store? Array of I equals to what? array of I XOR vector 1 of I minus 1. What we are doing, we are storing, means what we are doing is that we want to store at each particular location what we want to store, XOR of all the previous elements, XOR current elements. So this is what we are storing over here. Let's suppose we want to store the XOR at 2, so it will be equal to what, array of 2 times XOR of whatever is stored over here, that is XOR of 2 minus 1, right? XOR of I minus 1, whatever is stored over here. So that is what we are doing over here. So array of I XOR vector 1 of I minus 1. Let me explain this part a bit clearly. What I am doing is that we want to maintain this XOR array, right? So which XOR array stores XOR at a particular ith index, what this XOR array stores, XOR of all elements from 0 to I. Okay, so if I want to calculate the XOR at second location, so it will be equal to what, 0th element XOR 1 first element, XOR second element, right? But what we know that XOR of 1 stores what, XOR from 0 to 1. We know this XOR of 1 will be equal to what, 0 XOR 1. We know this is what this XOR array is storing. So XOR of 2 can be written as what, this can be written as what, XOR of 1 XOR the current element, that is this array of 2, right? This can be written as something like this. So that is what I have written over here, okay, for calculating the XOR array. Okay, after that let's make a variable, not variable, a vector of integer answer. Okay, now we'll travel on the queries array. So for integer I equals to 0, I is less than queries dot size plus I. Each time we will calculate the starting index. Starting index will be queries of I comma 0. Ending index will be what, queries of I comma 1 will be the ending index. Now what we want to perform, we want to perform the XOR. So what I have told you, that we will perform if A XOR B is given to us. So XOR of B XOR of A minus 1, something like this we will perform. So let's break it into two parts. Left will be what, left will be our array. We have stored the XOR in this array, ARR array. So array of starting index minus 1, and our answer will be what, let's make left part, let's make right part will be what, array of ending index. Okay, and our answer will be what, right part XOR left part, right? And finally we will not make, let's make this as well, answer dot push back well. Okay, now we need to handle one thing, like what if in these cases, like if 3 to 5 we want to calculate, then XOR of 5 minus XOR of 2 is okay. But if something, the range is something like this, XOR of 0 and 5, then in this case if we write XOR of 0 minus 1 minus 1, then minus 1 is not a valid index. Okay, so if the array starts from 0, in these cases we can simply return whatever the value is stored over here. Okay, so if starting index will be equals to 0, then we will simply return 0 in these cases. Okay, because our answer for whole segment is already stored over here. Okay, so in this case we don't need to perform an extra XOR. We can skip this part, means performing extra XOR, or we can perform XOR with 0 only, because performing XOR with 0 will not affect our answer. So if we will check that left part, if starting index, that is starting index, if it is equals to 0, then we will use 0 for performing XOR. Otherwise we will use array of starting index minus 1. Finally we will return answer. Okay, so this was for this particular problem. So you can use you can code this problem in this particular way. Currently the test cases are like not updated in our portal, so by the time you will code this problem, test cases will be updated on our portal. So you can use this particular way and you can solve the problem. Okay, so for now I will be not be submitting the solution since test cases are not updated. Okay, so I hope you guys would have enjoyed the video.